Hello class, this is a video tutorial on inverse functions. In this video, we'll be looking at finding the inverse of a function. First, let's recall what a function and its graph is. A simple way you can think of functions is to consider it as a machine. The machine takes an input from the domain and it has to give only one output based on the machine's instruction. So for example, here's our machine. F of x equals 2x plus 3, and this machine is going to be placed along its domain in the x-axis. So now what this means is when the machine is on, let's say, -2, which I believe was here, the machine takes the input at that point and it maps it onto another point based on its instructions here. So for example, if the machine gets to the point -2, the machine takes -2, runs it through the machine, and puts it to one spot on the number plane. So you've seen here, -2 goes into the machine, and what comes out is -1. If we put -1 into the machine, it runs its program or its instructions and it gives 1 and so on. From this, an inverse relation, okay, we'll get to this more detail later. An inverse relation is written as f to the power of -1 of x is one that reverses all the operations of a function. So for example, here is our inverse function. We'll put that in air quotes. And this inverse function goes on the outputs. Whoops. It goes onto the outputs like so. And from the output, so notice how now, from the output, when we place it into the inverse, it gives back the original input. So take a close look at these two tables of values. Notice how the input here gives an output, but in the inverse, when we take the output and we run it through the inverse function, it gives the original input. So an inverse of a function, it reverses all the operations done by the original instructions. So the inverse of this function is this one. So in a similar way, you can think of the machine, the inverse relation as a machine that takes the outputs and maps them back onto the x-axis. So it's reversing everything. To find the inverse relation, we simply switch the x and y in the expression y equals f of x, and then we make y the subject. Now to clarify, the inverse of f of x is not the same as this, because this one is the reciprocal of a function. So for example, if we place the index on the outside of this, it's actually 1 over f of x. So for example, going back to our original example here, this is our function. The inverse of this is this one. That's the inverse of f of x. But if we wrote it like this, there's f of x again. If we wrote it with a -1 on the outside, we simply take 1 over the original function. So I'll demonstrate to you this idea here, where we switch x and y, and then make y the subject to find the inverse relation. I'll demonstrate to you this one first. So this f of x is 2x plus 3. To find f inverse of x, we switch x and y first. So we write this as x is equal to 2y plus 3. And then from here, we make y the subject. I'm going to subtract 3 on both sides, and then divide by 2. I'm just going to switch places, so we get y is equal to x minus 3 over 2. And this here is the inverse of y is equal to 2x plus 3. After seeing that, you can pause the video and try these next 4 examples. So I'm just going to go through them right about now. So our function is 1 over x minus 2. We're going to simply switch x and y. And we make x this y the subject. I'm going to multiply by this group. I'm going to divide by y by x. So we get. Then I'm going to add 2. And that there is the inverse of this one. This one's a little bit easier, so let's switch them. X is equal to the cube root of y. To reverse this, we simply cube both sides, which gives us y is equal to x cubed. Here's where it gets a little trickier. We're going to switch all of x and y. So it's going to be x is equal to 6y minus y squared. This one's a little trickier now. I'm going to make this coefficient positive, so I'm going to multiply everything by -1. Watch carefully. And now I'm going to complete the square on this expression here. So take a look. Y squared minus 6. Actually, I'm going to switch everything around to make it easier for later. Now remember, to complete the square, we take half of 6 and square it. So half of 6 is 3, squared is 9. This will give us a perfect square, which is y minus 3 all squared, negative x plus 9. I can actually make this neater. I'll just write it as 9 minus x. Take the square root of both sides. We need to take positive and minus. And this gives us 3 plus minus 9 minus x all square root. And this is the inverse of this one. One last example. You can pause the video and give this a go. Just to make it easy for myself, I'm going to switch everything around. So it's going to become y squared minus 6y plus 8 is equal to x. So I switch x's and y's, and I moved everything here to the left hand side. Switched everything. I'm going to move the positive 8. Notice how I'm leaving space for myself here. I'm going to complete the square once again. Take half of this and square it. So half of 6 is 3 squared. The left hand side can factor into this. This will simplify into taking the square root of both sides and moving the 3 across. And that there is the inverse of the original function. So I hope that gave you an insight into finding the inverse of a function. Hope to see you in the next video. Best of luck.